I began using Sketchpad in geometry. From the very basic explanations in geometry, something as simple as you cannot determine a line with only one point. There have to be 2 points on the screen before it will allow you to construct a line. And to much more complicated, discovering that the limit of the perimeter of polygons with a fixed radius as the number of sides goes to infinity becomes the circumference of a circle.
Wait, so is your image congruent or similar?
It's similar.
Why?
Because it doesn't make an exact object. For example, notice that the original J is smaller than the final J.
Why is that?
Because when the objects are traced, one expands in size, so they're not congruent, they're similar.
Good point.
What Sketchpad has done more specifically is actually piqued their interest and given them the ability to start visualizing what's going on geometrically. If they couldn't picture it, they could make a sketch and they could drag it around and test things and see what happened.
You could construct things, measure, and do all the things you can do by hand, like with a compass or protractor, but so much more quickly and easier, and it's not as difficult. You just like press a button and boom, there it is.
And it's like really precise. It's more precise than using like a compass and a straight edge and stuff for your conjectures and constructions. Sketchpad like really helps us introduce it, and then we can see firsthand.
So we can say, okay, draw a rectangle, put in the diagonals, and now let's do some investigations, take some measurements, change the shape of the rectangle by putting the arrow on the vertex, drag the arrow. The measurements change as the shape changes. Students can then take a look at these measurements and they can try to find some patterns.
You can write your name backwards and use the mirror property to like mirror your name, so while you're writing it, it like does the same thing but backwards.
And we figured out what their properties were.
And there's like a lot of ways that you can construct the same object.
We worked with theorems. First, we would build them by hand using a compass and a ruler, and then we would work with transforming that into Geometry Sketchpad and being able to look at the measurements and see how specifically the numbers would change and have relationships. So we would build the interior angle theorem and the exterior angle theorem.
Well, I used it to prove theorems or disprove them occasionally. So you can test different types of triangles, scaling triangles, isosceles triangles, and that'll take you to a whole isosceles triangle theorems about the two base angles being congruent. And whereas if I were to try and do that on paper, I'd have to draw multiple triangles and then do the measurements.
I present a tile, basically, and it all starts from one little shape, and they have to figure out how to use the program and the commands to do all four transformations.
We investigate the Euler segment on the computer from the points of concurrency. Certainly could never do that by hand. It just is way too complicated and too messy, really, on paper. But on the computer, we can just put that in as a regular part of the curriculum now.
Drawing circles. It's really tough for me to draw circles, and in Sketchpad, it's really easier to draw circles, and it's accurate.
I think the ability to be able to construct something and then to grab onto a vertex and to expand or shrink the object and to see that the conjecture still applies, I think that's a good visualization tool for the kids.
See, the sizes are same when they're closer. When they're more apart, it's really big. So they're like more like congruent when they're closer to each other.
But like they're similar, right?
Yeah, but they are similar.
One of my favorite Sketchpad labs was when we were working with the parallel lines and transversals, because I could really see what was happening, and it helped me to understand what was going on with the angles.
Click the angles and then select them, and then like get the measurement, and then go into another application, like select the corresponding angles measurement, and just do it that way instead of having to go out and calculate it paper and pencil and all that.
You can see how like different theories like sine angle side theorem and angle side angle, how they affect different triangles so that you can see how they are congruent to each other.
I was teaching a class on Archimedean tessellations, which is basically composing regular polygons of mixed types to tessellate. And one of the students ended up creating different type of tessellations by creating ring-shaped constructs from regular polygons. These constructs relate geometry to number theory. So we are in the process of putting down something to be published.
What we're looking at on this bulletin board is a sample of student work. These are kids who, if they've had trouble passing math in the traditional ways, like for all of these kids, they produce light bulb moments. They produce something where the kid is getting it for the first time.
I feel that these two are the most accurate triangles, rectangles right now. Oh, it's same as the gold ratio.
Isn't that an interesting connection?
Yeah.